This is Group 17 for the course of Structure 2 to prepare the assignment about project design. The WILE design project is focused on developing an understanding of structural load paths and the design process. The design project is an industrial single-story building and shed. There are some members and connections for structural stability. The main members and connections include the cooling, on-dirt, on-bracing, on-cladding, and so on. It has several methods of connection in market. It can be pinned or fixed connection. We have chosen pin connection for our design. The members and the connection for roof systems. It may include wafters, roof shading, purlin, and so on. In the top of the roof, we can use a place bracket to connect the wafter. Load is playing a significant character when we design the building. In table above, it has shown the application load in different parts of the building. It has a lot of load we need to consider for example, daily load, leaf load, wind load, and so on. Our housing sites are located in Region B. The photographic effect is in Class T3. The building is using the parietal shading. Thus, we are select wind Class N4. The design wind span is from AS 4055 table 2.18. Serviceability limit is 39 and ultimate limit state is 61. Next, we can calculate the wind press and suction. For design the purlin, firstly, we can decide properties of the insulation and ducting from the Google in the market. A purlin is a horizontal member which carries roof deck or roof shading load and is supported by rafters, trusses, steel beams. Z-purlin is better than C-purlin. This is because Z-purlin can be lifted in continuous span and increase the capacity. For next step, to work out the W for downward and upward separately, then work out required numbers to order. According to the table dimensions of these and C's, the D of Z250019 is 215.4 mm and the maximum unbridged length is 5.08 m. After that, according to the load capacity, to decide the number of bridges. According to wind span and table 3.1 shape, suction and pressure, then there can work out W for upward and downward. Then, according to table C1 from AS 170.0. The ED combination can be selected from them. After that, from the side table, the load deflection span of choosing section can be given. Now, there can be given whether or not the section can be selected during comparing. Rafters are sloped beams that run from the roof ridges to the eaves. They provide the support for the external roofing material. Beam column connections are pinned joints, so to assume the rafters to be simply supported. Also, to assume that the roof loading will be transferred from purlins to rafters as uniform distributed loads. The rafter material in picture is steel, which is clear span distance. The first step is to calculate the support area. This is related to the load-bearing area in intermediate rafters and end rafters. Additionally, the purlin spacing that is decided previously, which should be used in this design. The next step is to get a compilation of action according to AS 1170.0 section 2.2.2. Finding the most adverse uniform distributed compilation under compression and wind action. The top fridge of rafter is restricted laterally against the backing about beam weak axis, and maximum unrestricted length of the rafter is 1.4 meter. The maximum unrestricted length is L equals to 1.4, which is rounded to 2 meters. The third step is to design the rafter during the first test. Using the capacity tables, we can use 180 UB 22.2 and the capacity is 37, which is more than M equals to 19.498. The fourth step is to check this beam for reserve act. This time the bottom flag is under compression and there is no lateral restraints for the bottom fridge, and the effective length is 4 meters. 180 UB 22.2 for LE equals to 4 meters. The capacity is 23.1, which is less than M equals to 25.16 kN.M. So this is not okay. Continuing to next step. This is must to design the flying bracing to connect to the rafter and purlin. Using flying bracing at every 2 purlins, so the maximum the effective length is LE equals to 2.8 M. Take 180 UB to 2.2 for LE equals to 2.8 M, which is 30.78. This is more than the 25.16 kN.M. So this At this time, this is okay for the flying bracing design. Because the self-mass of the rafter is 22.2, the day load of rafter can be calculated. Then, to combine the day load with sheeting and purlin. After that, to calculate uniform distributed day load for reservoir action. The seventh step to check the section for serviceability limit state. Firstly, to calculate the maximum deflection of the simply supported beam under uniform distributed load. There will use E and IX. IX can be found out in this table. Then, to calculate the maximum allowable deflection for the rafter. As a result, the deflection of 180 UB 22.2 is less than the allowable limit and is acceptable. There don't need to check bigger section for the rafter. 180 UB 22.2 can be selected for the rafters.
Columns are basically rigid vertical structure members being shown in these pictures. It is designed primarily to support the compressive load coming from the beam and the slab. Columns are very important members of our structures, therefore type of the column need to be chosen carefully. Let's go to the third part of this assignment, which is column design. In this part, we will design a column in a brace frame. We are going to use pin joint as our beam column connection. Therefore, we have to calculate the bending movement as well. The first thing we have to do for designing a column is calculate the supported areas. There will be two different supported areas in this project, which is known as intermediate column and end column. They will be designed separately in different sections. The second thing we have to do is calculate load combination for ultimate limit state. Before we calculate load combination, we have to calculate the maximum and minimum dead load. Dead load in this project include insulation, shifting, purlin, rafter, and tufting. After finish calculating the dead load, live load will be the next. If the live load kPa less than 0.25, then we will consider 0.25 as our live load. For the wind load, we have to calculate the wind pressure and suction. Lastly, we only calculate the load compression for the ultimate limit state. The load compression includes maximum compression force and tension force. After calculating compression force and tension force, we have to design for pure compression force by choosing the suitable type of column in this building. Display of maximum compression force and the LE length. After deciding which column type we are using, we have to check the section of column type for the perform capacity. The FFM shown here is the bending movement on the top of the column. After that, we check the perform capacity using capacity table 5.3. Make sure the M is higher than the capacity table. Furthermore, we check the column capacity by using these equations. This equation is available in page 217 in AS 4100. We have to make sure the number is not bigger than 1. Last but not least, we check the reversal action of the wind. If the number that we calculate is smaller than the number in the capacity table 7, column considered suitable to use. In this assignment, we have decided to use 100 universal column 14.8 for all the columns in the building.
The next structure we need to design is the bracing design. In construction, bracing is a system to reinforce the building structure in which diagonal support intersect. The bracing can increase the building capacity to withstand the side map activity. The vertical bracing, which means the bracing in vertical plane, will provide the root path to transfer the horizontal force to ground level and provide the lateral stability. The horizontal bracing will occur at each floor level. The bracing in horizontal plane will generally provide by the floor plan action. It provides a load path to transfer the horizontal force to the plane of vertical bracing. The bracing we use to transfer the lateral improved direction. Thus, we need to design the roof and wall bracing separately. In this assignment, we need to design the roof bracing and wall bracing, and we need to consider the direction of the wind. Thus, we need to consider all the wind direction when designing the wall bracing. This is the wind direction from north to south, and this is the wind direction from west to east. For thrust analysis, all the support reaction and member force was determined by the spyglass. For the diagonal member, it only resists tension. Thus, we need to remove the compressive diagonal member based on the position of the load applied. All the support reaction and member force were determined by spyglass. In this table, it was stated all the force reaction of all structural members. For the roof bracing, all the diagonal members will be designed as equal angle, and the compressive member would be rectangular hollow section.